Good day, grade 12 learners and teachers. Welcome to today's mathematics lesson. My name is Nsindane A. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saipono Discovery Center. Our lesson for today is going to be statistics, and we are going to be looking at two variable statistics, which is the analysis of bivariate data. Last week we were looking at univariate data, where we're looking at only the analysis of one variable statistics. Now, as we move along, please note our WhatsApp is working, and our WhatsApp number is 079 578 2908. Please, if you are having any questions pertaining to the lesson, send your WhatsApp messages, and it should be available at the bottom of your screen there. Now, by the end of the lesson, you should be able to differentiate between univariate and bivariate data analysis. You should be able to draw a scatter plot and comment on the relationship that exists between the two variables. We should be able to draw a line of best fit on a scatter plot, and we should be able to determine the least squares regression equation, and we use it for prediction. We can refer to our CAPS document on page 27 and 48, as well as our examination guidelines for grade 12 for 2021 on page 8. Our pre-knowledge, we know how to determine the mean, the mode, and the median. We are also able to determine the standard deviation. We know bar graphs, we know histograms, we know pie charts, we know frequency tables as well as frequency polygons. We know stem and leaf diagrams. We know our ogives as well as our cumulative frequency graphs. Now, I will give you 9 minutes to do the baseline assessment that is appearing on your screen. Please use your calculators and write your solutions. We will mark at the end of 9 minutes. Welcome back. I hope you were able to answer the baseline. Now we are given the data for the ages in years for people who visited the library between 8 a.m. and 9 a.m. on a certain morning. Now we are supposed to determine the mean, and we know how to determine our mean. So we'll quickly go through the solutions. It is the sum of all data items divided by the number of data items. So we got our mean as 38.07 years. Now you awarded a mark there, but if you gave the answer only and it's correct, you get your 2 marks there. Our median, our data is already arranged in ascending order. It is the middlemost position, and we'll get our median as 36 years. We get 2 marks there. Our interquartile range, we get our Q1 as 5, and we got our upper quartile as 66. Then we know that our interquartile range is Q3 minus Q1, and that will give us our answer as 61 years. So that's how you are awarded marks there. Standard deviation, we are using our calculators, and we got 26.39 as our standard deviation. We get our 2 marks. So far I know we are having 8 marks in the bag. We move forward. So please, let's continue to practice this so that we get used to our calculators and we do not make unnecessary mistakes. We're supposed to draw our box and whisker plot. So you will get a mark for the maximum and the minimum. Also, just indicate this is your minimum, this is our Q1, this is our Q2, this is our Q3, and that one is our maximum. Indicated there on your box and whisker plot. Now, we are supposed to comment on the skewness of our data, and we are going to say our data is skewed to the right, or we say it's positively skewed. Remember, for us to comment on the skewness, we are comparing the mean and our median, because we calculated the mean, we also calculated the median. If you check, our mean is greater than our median, therefore it's skewed to the right. Or if you say 38.07 minus 36, we get a positive 2. Hence, we say our data is positively skewed. Remember, that's how we determine skewness. We are comparing the mean to the median. Hence, we get it as positively skewed. Let's move along. Now, we defined data handling and will continue to define it. It is the process in which data, where we are dealing with numerical information, is collected, recorded, represented, and analyzed. Now, and we know that data is facts and numerical information that is being analyzed. It can be univariate or bivariate. In other words, univariate is when you are dealing with only one variable. For example, the data that we just analyzed, we are just dealing with ages. Whereas bivariate data analysis involves the analysis of 2 variables for the purpose of determining the empirical relationship between them. We must be able to check whether there is a relationship between the marks that you obtain in mathematics and physical sciences. If there is, we want to find out the strength of the relationship. Can we conclude that those that are passing maths are also passing physics using numerical and statistical information to back our deductions. So moving forward, there's another term that we are going to use a lot. It's called correlation, which is any statistical measure that expresses the relationship between two random variables. And we are saying we use a scatter plot, which is the graphical representation of the relationship between the two variables. We place one variable on the x-axis and the other on the y-axis. Now, we plot the corresponding values of the variables as coordinates on the Cartesian plane, and we use the equation of the least squares regression line, which is written as y hat is equal to a plus bx. Now, our a is our y-intercept and our b is the gradient. But on our formula page, we'll be able to see how the b is calculated. But for our purposes, we will not use that formula. We are using a calculator to determine those values. The least squares regression line always passes through the point where we have the mean for the x values and the mean for the y values. Now, we use a correlation coefficient, which is represented by small letter r, which is a numerical measure of some type of relationship between the two variables. And the least squares regression analysis is a method used to determine the line of best fit for the data set. And we are going to look at the linear trend for our correlation. We have three correlation trends. We have one that is linear, we have another one which is quadratic, and we have another which is exponential. But for our studies, we'll only focus on the linear trend. I know as you further your studies, please note that you might be expected to do the other two trends, but I'm saying for our purposes in grade 12, we are only going to focus on the linear trend. But you must know that there are other correlation trends that exist. So we are going to focus on the linear trend, and we have the quadratic trend, where it just tries to represent the shape that you form using our scatter plot. You draw it after you have plotted a scatter plot. So for our purposes, we are going to focus on the linear trend. These other two, it's just an illustration. We are not going to do problems that focus on the two trends. Ours is the linear trend only. Now, we have the correlation for the linear trend. It can either be negative or positive, or it can be a non-linear correlation where we fail to draw a line of best fit. The points will just be scattered all over. If you check, you will observe that our points on the scatter plot seem to be increasing from left to right, and we say it's a positive correlation. And then we have a negative correlation where the points plotted seem to be forming a decreasing trend, and we call it a negative correlation. And then we have where we have no correlation at all, where the points, we can't actually give whether the points are having a positive or a negative trend. Moving forward, we use our correlation coefficient, which is a numerical value between -1 and +1 that measures the strength of the linear relationship between the two variables. So the more the points deviate from the regression line, the lower the correlation coefficient. But if the points are closely packed together and are increasing, it means that there is a strong positive correlation. If the points are closely packed together and are decreasing, we'll have a strong negative correlation. If points are fairly spread out, we'll have a fair correlation. It can either be positive or negative. Now, we have our correlation coefficient table and how we comment about the strength of the relationship. If we have it as either -1 or +1, we will say it's a perfect correlation. But remember, the sign is also important. As you can see, it can either be negative or positive. I have added that other table for you to also see. In most cases, if we are saying at 0, we say there's no correlation between 0,1 and 0,3, either positive or negative, it's weak. Between 0,4 and 0,6, we say it's moderate. Between 0,7 and 0,9, it's strong. And some literature always says above 0,9, we say it's very strong. But the key words there, it's the strength, whether it's strong, and the sign, whether it is positive or it's a negative correlation. We need to put those. If they are not there, we may lose marks. We can't just comment and say the strength is strong. We must always give whether it is a positive or a negative strength so that we are able to see the strength. Now, we are going to plot a line of best fit, and I've indicated that this is a straight line which passes through the point where we have the mean for the x, variable x, and the mean for the variable y. And to sketch it, we need 2 points. We need the y-intercept or the x-intercept, as well as the point where we have our x bar and y bar. Now, we connect the points using a straight line, and we can use the least squares regression line to predict the most likely x value or y value depending on what we are given. And we are saying the stronger the correlation, the more reliable our prediction will be. So when we are plotting our line of best fit or our regression line, we can either interpolate, which is interpolation. You want to find a value within the given range of our x values to determine our y value. It has to be between the smallest x value and the largest x value for the given data set. Extrapolation, we are saying our x value might be outside the smallest and the greatest x value in the given data set. Now, we need to emphasize this. The linear trend observed for the dataset does not always continue beyond the given range of values. Hence, when we are plotting our line of best fit, we must make sure that it's only covering the data that we are analyzing. We cannot just stretch it across the whole graph. Otherwise, it's the reliability above the greatest x value and below the smallest x value may not be guaranteed. Now, our formula for statistics that we find in our formula page, we know that's our mean. We know that's how the square of the standard deviation gives us variance, and the square root of the variance gives us standard deviation. We have our least squares regression line, and that is the formula that is used to determine the value of B. But for our purposes, we are using a calculator to determine B, but we must just know how it comes by. Now, for our calculators, we go into stats mode, and for our purposes now, we will go to option number 2 because we are doing regression analysis. Now, I'll quickly go over the example. Because we do not have graph papers, it might be a challenge for us to draw the scatter plot, but I'll give you a chance to use your calculators to try and determine the least squares regression equation. So you go to option 2, you enter your data values, and then you should be able to determine the values of A and B. 3 minutes, let us use our calculators. Welcome back. So we are given the table that shows marks obtained by 10 learners in mathematics and physical sciences in a certain class for June examinations. Now, we are told maths and physical sciences, so we want to analyze the strength of the relationship and see whether there's a relationship between the marks obtained in maths and physical sciences. So we are supposed to draw a scatter plot, but because we do not have a grid, I will have drawn the scatter plot for us. Remember, it is important to check the scale of the grid. In most cases, you'll be given this in your answer book. So that is how you determine which one is your X and your Y. If they're like this one, it's not indicated which one is X, which one is Y. So this is your X, this is your Y, because it's on the vertical axis, horizontal axis, we have maths. So how we plot the points, we are having maths is 24. So you are able to see that on our x-axis, each of the smaller blocks seem to be representing 2 units. And if you check again this side, each of the smaller blocks represents 2 units because we are having 5 divisions there. So 24 and 34, my X, then my Y, I indicate with a dot. It will give me, and I must make sure that my points are 10. You plot each and every point correctly, and there are marks there. So you will get your 3 marks for plotting all the points correctly. We move on to the next part. We are supposed to use the data to determine the least squares regression equation. In other words, our least squares regression equation, we know that it's given by y hat is equal to a plus bx. So our job is to find the values of a and b. Then we substitute them into our equation. From our calculators, I asked you to add this information in your calculator so that we'll use it as we do this example together. So that's how we did it. And then we had this screen appearing. Depending on whether your frequency on your calculator is on or off, you will have your X and your Y values. You enter your X and Y values there. After you are done entering your data, please save. Depending on the type of calculator that you are using, you save your data, then you shift, you go to states mode, and then we are going to be using this option 5 according to this type of a calculator. You choose option 5 and you are able to get that menu. So our job is to find the value of A and B. So you will press 1, you press equal sign, it will give you the value of A. You then move option 2, it will give you the value of B. And then I'll encourage you, once you have done this, write all the information in your answer book before you even look at the questions that are below, so that you have all the information that you might need. Get your value of R. Also, whilst you are there, you can now use option number 4 to get your mean for the X values, your standard deviation for the X values, your mean for the Y values, and the standard deviation thereof. And then you keep them safe somewhere. You get your mean, for the Y values, you also get. So from this, we are able to get our A as 34,929. Please, I'll encourage you, write your value of A. Also write your value of B. Then when you write the equation, you round them off to 2 decimal places in your answer book, and you will get your equation as that. So you'll get a mark for the value of A, you'll get a mark for the value of B, and you get a mark for the equation, the value of A and the value of B in the correct positions. Now, the reason I'm encouraging you to do this is so that we do not unnecessarily make mistakes. Because some, they interchange the values and they have not indicated which one is A, which one is B, and in the process, we might get things wrong there. And we lose marks if we have not indicated which one is A, which one is B, because we benefit for those values in case we swap them when we substitute on the equation. We should write the value of A, write the value of B, then write the equation. That's when you get the 3rd mark you round off to 2 decimal places because those are the instructions in our question paper. We move forward. We are supposed to draw the line of best fit. Now, I indicated that for us to draw a line of best fit, we need a y-intercept as well as, and we said the y-intercept is the point where we have our 0 and A, and we also need our point for the mean for the x and the mean for the y, then we join the points. So we have our mean for the y, our mean for the x, and we know that our y-intercept will be 34.93, which is almost 35. We draw our line of best fit like that. But remember, we said our line of best fit should not extend beyond, and it should not extend beyond, because once it extends beyond, its reliability cannot be guaranteed. So we must always make sure it starts where our x values start. So our smallest x value there is 20. So our graph must start here and it must end on the last point there where our x value is 74. It must end there. This part, you erase it. We are using a pencil, you erase this part. It should not be there on your final answer for the scatter plot. But this one, you can indicate it either using a cross or something which is different from the dots that you have used for your scatter plot. Now, we know those are the points. You can see now what I've done. I've cut those points and my graph starts there and it ends there. That is our line of best fit. It should only cover the points, smallest x value up to the biggest x value. It shouldn't extend beyond those points. Now, you will see this. So the final answer that we have for our scatter plot is that one. So you will get your 2 marks for the line of best fit that does not extend beyond and it passes through the point x bar and y bar. You get your 2 marks there. We move on. Question 1.4 asked us to write down the correlation coefficient, and again we are using our calculators. That's our R. We got it as 0.46, and in most cases we should comment on the strength of the relationship, or sometimes you will be asked, how do you comment on the strength of the relationship between the two variables? Justify your answer. So you can use your R as justification, and then you are able to comment whether the strength is weak, linear, positive or negative, strong, or you can say it's moderate, depending on the value of R that you get. So for this, our R is 0.46, and you are able to see in our scale where our R lies. So it's a moderate positive correlation. You get your mark. If the 11th learner obtained 54%, and if you check 54% for mathematics, it's still within our range of values. So we are interpolating, or we are doing interpolation. So we are going to use our least squares regression equation to determine the physical sciences mark. So we'll substitute our x as 54 and we get 54.91, and you can leave your answer to 2 decimal places, or you can round off and get the physical sciences mark as 54%. With this being said, I will ask you to answer the activity that we are having there. I will give you 8 minutes to answer the first activity. Welcome back. I hope you were able to answer those questions. I realized we do not have the graph to draw our scatter plot, but I would advise take a photo so that when you have a graph paper, you practice the sketching of the scatter plot so that you get used to it. Otherwise, sometimes sketching can take a lot of our time. And remember, if you are having any questions, our WhatsApp line is 079-578-2908. Now, we are given the relationship between age and spending money on buying clothes per month has been studied for years. Research has shown the following results. Age 21, amount spent in rands, it's 1,534. Age 27, amount spent 1,260. Age 35, amount spent 986 rands. Age 42, they spend on average 810 rands. Age 55, they spend on average 450 rands. Age 63, they spend 250 rands. We draw our scatter plot. Remember, I've indicated when you are drawing your scatter plot, your points. So our age is 21. Check this side. Each of the smaller blocks represents 2. So that is why that point is on the middle of the block. And if you check this side, you are having 1, 2, 3, 4, 5 divisions, which means each of these smaller divisions will represent 20, no, it will represent 40 rands. So 40, 80, 120, 160, 200. 240, 280, 320, 360, then we have 400. So we must be able to use that. So we represent 1,534, we represent 1,260 with age of 27. So our age, we check it here, 27, it's 20, 22, 24, 26, 28. So 27 is in the middle of the block, and then we plot the amount there. Now we plot all the 6 points, and then we get our 3 marks for plotting the scatter plot. And from the way we see it, the points are forming a linear trend that is decreasing from left to right. Now we join the points. For the 1.2, we are supposed to determine our least squares regression equation. So we are using our calculators there. We got our A as 2085,43. Our B, we are getting negative 29,722,4552. Now we get our equation as such. So this will be our mark, and for our equation. And then our 4th mark is for drawing our line of best fit. And we are saying our line of best fit must pass through X bar and Y bar. That's our mean for the age and our mean for the amount spent, which will give us 881,67 rands. And we draw our line of best fit. Remember, we said our smallest X value is here. It starts there and it ends where we have our age, the highest age in the given data set. Now we get our 4th mark there. We are supposed to describe the trend of the data in reference to the correlation coefficient. The correlation coefficient, we are using our calculators. So we go to our calculators, we get the value of R, and we get our R as negative 0.9995. Now, and this is a very strong negative correlation. If we round up to 2 decimal places, this will give us -1, which could give us a perfect negative correlation. But for now, we will leave it at that. So describe the trend of the data with reference to the correlation. So you get a mark for the correlation coefficient and a mark for the description of the trend, which is very strong negative correlation. Strong negative, that's where you will get a mark. We are supposed to estimate the expenditure of a 50-year-old person from the scatter plot. Now, we are going to use our equation. We substitute and we should get our solution as 599.43 rands, which is almost 600. But we can accept any answer between 595 and 605. And you can see if the age is 50 years, I reach the graph, then I'm able to estimate as well using the graph. If I trust my line of best fit, I'm able to see that the amount spent by a 50-year-old is around 600 rands. I hope you are seeing it there. So in case they've drawn the scatter plot for you and drawn the line of best fit, you can actually use the given graph to help you get, in case your equation is also not correct, but you should trust your equation as well as trust your graph. Moving forward, I'll ask you to do the following activity. I will give you 4 minutes to answer 2.1 and 2.2. Welcome back. I hope you were able to answer these two questions. Right. We are told on the first school day of each month, information is recorded about the temperature at midday in degrees Celsius and the number of 500 milliliter bottles of water that were sold at the tuck shop of a certain school during the lunch break. The data is shown in the table below and represented on the scatter plot. The least squares regression line for this data is drawn on the scatter plot. Now, they have done the scatter plot, they have also indicated the line of best fit, and you are able to see that it does not go across the graph, but it starts and ends where our scatter plots starts and ends. We are supposed to identify an outlier. We talked about outliers when we were doing our univariate data analysis. So in this case, an outlier becomes a point that is furthest from our line of best fit, in which case we are able to see that there is a point that is plotted there, which is furthest from our line of best fit. And if I check, I have this point, it's closer. If I look at the distance, I have that one. These other ones we can see they are closer, closer, closer. The distance is so small. So the point that seems to be on its own is that one, and it will give us, it's when we have our x as 30 and our y as 53. Now, so that becomes our outlier because it is the furthest from our line of best fit. So you'll get 1 mark for identifying the outlier. We have to determine the equation of the least squares regression line. Remember, we are using our calculators. We should get the value of A, and we found our value of A as negative 38,51, 0.48532. And our value of B is 2,680047,933. And that's our value of B, our value of A, and then we get our equation as negative 38,51 plus 2,68x. We get our 3 marks there. Now, I would ask us to answer that question. 2 minutes. Welcome back. We are supposed to estimate the number of 500 ml water bottles that were sold if the temperature was 28 degrees. Now, we are going to use our least squares regression equation, and we got our y is equal to negative 38,51 plus 2,68. We substitute the temperature of 28 degrees and we should get our number of water bottles as 36,53. Now, if we check from our graph, we are having 25 and each of those smaller lines represent 1 degree. So if I check, this will be 26, 27, 28. And then we can use our line of best fit up to the graph. When we get to the graph, we are able to estimate, use a ruler, and still it will give us 37 bottles of 500 milliliters of water. We move on. The second one, we are supposed to use the data. We will have to comment, so I'll give you 2 minutes to answer that question. Back. So we are referring to the scatter plot. And remember, for us to comment, we should use our correlation coefficient as motivation. So in this case, if you check from our calculators, we should have gotten our R as 0.978947572. And this is going to be strong because our R value is 0.98. It's a strong correlation. It's a strong positive correlation of 0.98. Now, the last question, I will give you 1 minute. No, let me make it 2 minutes. You give a reason why the observed trend for this data cannot continue indefinitely. Please think and answer that question. Welcome back. So we are seeing that as the temperature increases, the number of water bottles that are bought also increases. But now we have to give a reason why the observed trend for the data cannot continue indefinitely. I wonder what you gave as your response. It makes business sense. As temperature increases, more water is sold, more money goes to the tuck shop. But this trend cannot continue indefinitely. Our reason is the temperature cannot continue to increase as this becomes very detrimental to our life. So, as a reason, we said the temperature cannot rise beyond a certain point as this becomes life-threatening. So, temperature cannot increase beyond a certain value. Otherwise, there will be no one to be buying those water bottles, as our bodies can take only certain temperatures beyond which we cannot survive. So these are the questions that you will find in an exam, which require you to give a valid reason that is making sense. Please do not leave them. You must answer them, because some of them are just general knowledge, but they require you to think outside the box. The last activity for the day, we are supposed to determine the mean. So I will give you 3 minutes to answer 3.1. I'll come back. So to determine the mean number of water bottles, now we are focusing on the block for the 500 ml water bottles. So we want to find the mean for that data set. We go back. Our definition for mean, it is the sum of all data items divided by the number. And we are able to see, we are going to add 12, 15, 13, 31, 46, 51, 53, all of them. We add them together, we divide, we get 434 divided by 11, and we get our mean as 39.45 bottles. So that's our mean. 3.2 and 3.3, I will give you 5 minutes to answer those two questions. Welcome back. For the information on the statement is still the same, and we are still focusing on the number of water bottles. So we want to calculate standard deviation, and we are going to use our calculators. Now, please note, because this information you have already punched in your calculators as X and Y, so we are going to use our Y. We got our Y bar as 36,53. So that's our Y bar. Sorry, no, it's 39,45. We got 39,45. Now, our standard deviation, we are using our calculators. We are going to get it from the calculator, and our standard deviation is 20,34. That's our standard deviation, 20,34. We get 2 marks for using the calculator. 3.3 is saying, on how many days did the number of water bottles sold lie outside one standard deviation of the mean? Now, remember, we used this in our univariate statistics analysis, one variable statistics. So we know that our mean is that one. So using our knowledge, we know that this means we have to find the interval where we have mean minus 1 standard deviation, and we have our mean plus 1 standard deviation, and we get our interval, and we should get our interval as 19,11 and 59,79. We go to our table. We count those that are below 19. We'll have 12, 13, 15, 31 is within, 23 is within. So these ones are within, and 63 is outside, 53 is within. So we are left with 70, 63, and 23 is within. So we count, we are going to have 1, 2, 3 that have ticks, 4, 5. So it means on 5 days, the number of water bottles sold were outside one standard deviation to the mean. And remember, for this question, they can ask it differently. It can be within. If they said within, we're going to take all those that have crosses, and that would have given us on 6 days. Sometimes they can ask the percentage of days. So if they've asked us about percentages, it will be 5/11 times 100. And then we give our answer as a percentage. Again, they can ask us within, below, above, outside. So they asked us outside, and we were able to answer it as 5 days. So you will get a mark for the lower value, upper value, and for getting the 5 days of the interval there. So it will be 5 days. We get our 3 marks, we get our 2 marks, and we get 5 out of 5 in this case. With that being said, we will move on and summarize our lesson. The scatter plot is used to represent the analysis of bivariate data, meaning we are looking at 2 variables. We are analyzing the data using 2 variables. So the determination of the least squares regression equation, we must know how to determine the equation using our calculators. Y is equal to a plus bx. We should be able to use the least squares regression equation to draw the line of best fit and also to predict. Remember, we can be given the number of bottles, we can determine the temperature for a particular day. That is, we use interpolation or extrapolation, depending on the question. Now, the correlation coefficient is used to determine the strength of the relationship between the two variables. And finally, we must be able to use statistical summaries and graphs to analyze and make meaningful comments on the context associated with the given data. With that being said, our next lesson on the 13th of August will be focusing on probability theory. That is the revision of probability in grade that we did in grade 10 and 11. So please, let's continue to practice mathematics, and we make sure that we watch the lesson next week again. Thank you. Have a good afternoon.